Good morning, good afternoon, good evening, depending on where you're joining us from. Welcome back to another episode of SAP Hands-On Devs, where we have been, over the past 8 weeks, been rebuilding the HANA OpenSAP Cloud project, updating it for HANA Cloud services, as well as the latest version of the Cloud Application Programming Model. And just to recap where we are, last week Rich Heilman joined us and we took a deep dive look into SQL Script. And really with the completion of SQL Script, we're now pretty much done with our database level modeling. We've covered a lot of different aspects. We've created our basic tables and views using both the Cloud Application Programming Model as well as HDB table and other DDL-based artifacts. We've seen cross-container and cross-schema access. We've dealt with synonyms, database-level security. As of last week, stored procedures, functions, libraries as well. We had also seen previously how to bring in our and do our calculation view modeling, which we had to do in the SAP Web IDE, but then brought it back over into our project, and we continue to work on it here from the SAP Business Application Studio. But with that, we've got a very robust data model. I think we've got all the pieces that we really need to build out the rest of our application, which up to this point has been really focused on the database layer and just doing a minimal amount of service enablement. But for today's episode, that's really what I want to go further into, which is creating our service layer and going from the very basic, what we get just out of the box with Cloud Application Programming Model and the built-in service handlers, but really see how we can enhance those as well as build our own custom service endpoints and other server-side logic into a single module that will be integrated fully into the Cloud Application Programming Model as well. And returning to our project in the Business Application Studio, let's focus in on the SRV folder. This is our service module. And right now, there's really not much in here. We have the default env JSON for connectivity parameters to the database, but we also have just this service.cds. And we've looked at this briefly in the past, but we kind of glossed over what it was doing. This is where we define our OData services, or our service endpoints, I should say. We'll talk a little bit more in a moment about OData or other options there. But really, we are defining our service endpoints in a technology agnostic way. It's not specific to OData, that's the default. But what we have to do here in this file is we basically just import the entities or views from our data model that we want to utilize the service layer. And that's what you see here at the beginning of this file. And then we declare our service. So we're going to declare something called service master data service. And we have the ability with an annotation to customize the path on which it occurs. We'll maybe come back to that here in a second. And then the entities that we want to make up our OData service, like address, employee, user, we declare those entities as projections on the underlying entity, and the names don't have to be the same here. We do have the ability to override or enhance the descriptions if we want at the entity level using annotations. We also see here that we have some that are going to be read-only, so based upon views, as opposed to entities that would have full create, update, and delete operations built into the generic service handler as well. And that's essentially all that we're doing here, is defining either tables, entities, as the source of our service endpoints or views. And with this little bit of definition, what we can already do is we can come here from the command line, we can just do a CDS serve, and it's going to process. It looks into our project and it sees what we have here. Yes, the data model, but more importantly, it sees in the SRV folder we've got service.cds. It's connecting to the HANA database, and we see that it is connected to local messaging for any messaging services, but it's serving master data service at master data service, the URL path, and that it's running on localhost right now. And then we can go ahead and click on the open a new tab to be able to test this. And this just brings us up to a CDS framework provided little introductory page or test page that lists the services in our application, the slash master data service. If we go to that, you see, yes, slash master data. It lists the entities as we've defined them in that service.cds file. We have a metadata document. And if I run this, it's going to bring up the OData metadata. Now this is OData v4 by default. We'll talk in just a couple minutes how we can also supply OData v2 interface as well. But this is the full metadata definition of our service interface, all the data types of all the various attributes, and any annotations that we've layered in as well. Now, there were very few annotations used here at the service level. Most of them are being inherited from things that we did at the data model level. Later, we're going to see how we can also add in like Fiori elements specific annotations as even a separate file, and it will be served out through the single metadata endpoint as well. But already we have annotations in here for column descriptions, language dependent column descriptions and things like that are ready to help us with our user interface consumption as well. And from this test tool, as we've seen in the past, we can come in here and we can access the individual entities, and we're seeing the data. We even have the ability, there's an entity, and if we were to run it in Fiori, depending upon the annotations that we have configured, and I don't think we have very many configured yet, so a lot of this may not show up great in the Fiori preview. Well, and perhaps we'll skip the Fiori preview part today, because this was working last week, but I did update the CAP version. It seems like there's a problem here now with running and being blocked by a CORS policy. I'm just running the standard CDS serve here, so I don't know if something changed and needs to be updated in the configuration. But for now, that's not really material to what I wanted to show you, other than I was maybe going to hope to show you that I could easily update data as well. The Fiori UI would have made that simpler to do. But that's really for a later exercise. We're going to create some of our own Fiori UI elements, or Fiori UI applications, and maybe in a moment here I can also troubleshoot the Fiori preview. But for the most part, what I wanted to demonstrate is that our service is running. It has all this robust capability to do create, update, delete, but we've done no coding. If you look here in the service module, there's no other JavaScript files, there's no other logic anywhere in the application. Everything you see here so far is being provided by the generic service handlers. And that gives us a lot of power right out of the gate and a lot of capabilities. But now what we want to do is see how we can enhance what is provided and have the ability to break out and do some of our own service handler implementations, and also how we can integrate our own logic into a cloud application programming model service that breaks out of that programming model and lets us use any native, in our case, Node.js development approaches or tools that we want. Okay, and we're back, and I apologize for the little error that I ran into there. It does seem to be some sort of incompatibility between the Fiori preview of the Cloud Application Programming Model and the specific version of Fiori, or more specifically, SAP UI5 that I was using. And if you don't specify a version, it automatically defaults to the latest, which at the time of the recording was the 1.81.1 version. And what I'll show you here, this is sometimes when you run into these errors, it's good for the purposes of being able to demonstrate a feature. And in fact, for the preview, for the CDS preview, we can do some configuration on it. I went into the package JSON at the root of my project, where most of the rest of my my configuration that affects the Cloud Application Programming Model resides. I added a preview section, and then a UI5 section within there, and then version. And I can specify a specific version. So this 1.81 version was where we were having a problem. Let's go back to 1.80.2. So let's just force that to go back a version. And now, without changing anything else, let's do our CDS serve once again. And open a new tab. And now when I do the Fiori preview, just want to make sure that it's bypassing the cache. And now it works. So apologize for that incompatibility we ran into. Sometimes those things happen. Particularly, I just updated the CDS version. I'm not sure where the incompatibility came from, but as you see, by going back a version in the SAP UI5 SDK, we were able to get around that problem. So not a terrible thing to run into, since it gave us an opportunity to showcase how in the Fiori preview of the Cloud Application Programming Model you can do some configuration, which people might not have been aware that was possible. All right, so now getting back on track after that little escapade there, let us start with what we really wanted to look at here today, which was being able to extend the built-in service functionality. So what I want to do, we got a service.cds. I actually want to add my own custom handler in here. And what I can do, there's a little bit of magical file naming that we can utilize. And all I have to do is create another file with the same name as my service.cds. So naming it service. Now, that name service could be whatever. I need to match the same name of whatever I name my CDS file, but give it a .js extension. And this will automatically be pulled in by the runtime as a service handler, a custom service handler. And what we're able to do here, let me just bring in a little bit of code. Oh, and I didn't get a very clean cut and paste there, did I? Actually, I wanted to one more line there on my linting. And we'll just close this out. There we are. So what we're doing is we're saying in this file, it's going to function as a CDS service implementation. Okay. We actually don't need these other two for now because we're not using those yet. But I want to declare the buyer entity, because that is, I'll tell you what, let's put these side by side. So what we want to do here is we want to take the buyer entity, and we're going to use the event this before the read operation. So we've got different timing event handlers. We can use a before, we can use an after, we can use an on to override whatever operation we're specifying for whatever entity. In this case, we're doing the before, which means this logic will execute before the standard event handler, and the standard event handler will still be processed, but it gives the opportunity for us to maybe override some of the processing before we actually get into things. We can say which action we want to do this on. We only want this to be on the read action. But where this actually maybe gets more interesting is on create or update to add our own custom validations that go beyond what we could do in annotations alone. We can drop into some additional processing at this level. And we're saying what entity we wanted to do this for just the buyer entity. So this won't fire for any of the other entities. And then we go into our event handler processing where we can write logic. For now, we're just gonna do a console log to say that we're in the buyer event, and this would just let us test and make sure that this is all working. So let's go ahead and save that, and let's do a CDS serve. And what we should see right away is now we see our SRV service.cds. We don't see any other changes there. Still serving our master data service. But now look at this. Implementation SRV service.js. So for this service, it's picked up that we now have this exit handler in our SRV module named service.js. We didn't have to configure that. It's the sort of automagical fact that we gave it the same name that allows the cloud application programming model to pick that up. And now when we come over here and test, we put that in the buyer entity. So first let's do a read on one of the other entities. Let's go to addresses. All right, we did a read on addresses. Nothing in the log except the fact that we did the read to the addresses. But now let's do a read to our buyer entity. Let's go to buyer. There's our buyer data. But we see our console log message has gone out as well. So we know that we triggered our event handler before the read operation of the buyer entity, because we got our output here in the log. The console log in buyer got triggered. Now we could do other things. What you see here is this is actually emitting an event here to let any event listeners know that the PO is changed or the data is changed. This was something I was probably testing out just to see if I could throw events. Doesn't necessarily make sense to do it in the read of the buyer to throw a PO changed event. I was obviously just testing something there, which is why it's commented out. So you can kind of ignore that. In fact, keep it from being confusing to anybody. We'll just go ahead and take that out. So that's the basics of how we can introduce our own event handlers. Let's see how we can now impact some of the other aspects here. For instance, let's say I want to check something here real quick. Second. Yes. Let's say I don't like the... I'm not sure I want to maybe impact the URL that we have here. Maybe instead of /master data service, let's see if we can change the path here. OData before master data service. Let's go ahead and save that. And now let's test that change. So what we see now, we're serving master data service at /odata v4 master data service. So I'm preparing for the fact that maybe we're going to have different service implementations or different technical endpoints for this service. And I want them to run on different paths. So now when we come over here and we test this is now OData v4 master data service. And all of our URLs that are generated for us are adjusted to that, and the service is now listing on a different URL path. And to effect that change, all we had to do was just use this path annotation here. Now, likewise, let's say, let me come back here, and let's say we want to not use this automagical naming here of the for the handler. Let's say instead we want to specify where our handler is going to be. So in this case, and I think, we'll test that in a second, I'm saying I actually want to put all my handlers in a separate file, or separate folder. Actually, that's not the file I wanted. I want to call this master data service handler.js. But let's create a folder here in SRV. Say folder handlers and create a new file, md service.js, and let's take this service.js and let's move it into our md service. So now we've got an explicit naming instead of this automagical matching by name. I kind of prefer that. Now let's see. I pulled this from an example, and I'm not sure my relative path here is right, but we'll test it out, and we'll know real fast whether that's the case. Let's do a CDS serve. Yeah, it does not like that. I thought that would give me a problem. Oh, why is that? There we are. Now I have it. So what I wanted to say, because the service is already relative to the SRV folder, then I was able to use the handlers folder within SRV by just saying from anchor from the root of where I'm running from, and then it's in a folder named handlers, and the implementation is going to be named md-service.js. So what we now see is serving master data service at odata v4 master data service, implementation coming from service handlers md service.js. And because it didn't blow up when I ran it, I'm going to assume that's working right, but let's go test this real quick. Let's just run our, we put that in buyer. Let's run our buyer service again. So again, we get our data, and now we get our console log for in buyer. So we've seen how we can use the sort of automagical naming to tie a custom service handler in, or how we can explicitly configure it using annotations, and how we can configure other aspects of the service like the URL without having to get into doing our own custom bootstrapping, but just using annotations here. And personally, I like this approach, even if I were, even if I could do the file with the same name and an auto match, I like it having it explicitly called out. There's just it's just clear when I look at this. I know exactly where that logic is coming from to do the custom service handler, and I don't have to guess whether it's a matching name. As we'll see here in a minute, if we add multiple services to our single CDS file, that allows us to have separate handler files as well for separate services in the same root file. All right, and what I've done during the break while I had the video paused is I went ahead and I added another service to our service.cds to demonstrate how we can have multiple services. And what we have here is we have a mixture. We've got a master data service, which allows us to create updates and deletes on some of the master data entities like employees or business partners. So it's primarily driven to maintain this master data. But what I've added is a second service called PO service with a similar handler, exit handler, which we haven't done anything with yet. We'll come back later to that. But also customize the path. I've brought in the master data entities so we can have associations, navigations to them, as well as expand those entities in line to get master data details as we read our purchase order entity details, but making those read-only so that nobody can try to insert a new business partner via the PO service itself. But then we have our purchase orders. And notice for these, I've also used the annotation odata.draft.enabled, which is going to give us Fiori draft support for these particular ones. And then for different UI scenarios where I might want to implement them on the same base entity, the headers entity, the PO headers, I've got one version with draft and one version without draft. And then the same thing for the item association. I redirect to two different inner entities here. PO items, which is the one that has is the basic one, but then I've got a PO items no draft for the redirect of the association there. So this is interesting because not only are we seeing how to configure and enable Fiori draft support for our entities at the service level, but also how we can override and redirect associations for different entities, as long as obviously the definition, the keys of that association match. But it would, for instance, maybe allow us to redirect to a view with additional data or additional associations in it as well. We actually do that in some of the other instances here, where product images I'm redirecting to the products entity in this case. Partners redirected to business partners. So we have the ability to override those associations at the service level as well. So a few other things here, like we have a function. We actually have two of those. We'll come back and we'll talk about the functions later. For now, we'll stick with the basic service. So now when I run this, if I do a CDS serve, what you'll see here is now we have master data service with its own implementation handler, the separate PO service, different URL at its implementation handler. And if we open the test page, we see both of our services. We can still access our master data services from the PO service, but now they are read-only. And for instance here, if we would go into the POs and say do the Fiori Preview, because we have draft support enabled here, we also have, we can see things like, let's go ahead and do partner, purchase order, ordering status, net amount, currency, and run the query. We do have a create now in our Fiori Preview, which if we try to do the create, it's going to ask us for a purchase order ID, which is a little hard to fill in because it's a GUID, but we could go put a valid GUID in there, and then we would be able to create one via the test interface here as well. But for now, this is just a Fiori test interface, like we said, but we see that already being pulled in and supported there. So we've seen how we can add multiple services to our single service definition, how we can do handlers, custom service handlers for different events, how we can customize a lot of things with annotations. Next, we want to see how can we also break out of the cloud application programming model and have some of our own custom service endpoints implemented in the same service handler as well. Well, and that's about all we want to cover for today's episode. We've seen how that we can influence the standard event handling in our cloud application programming model services. This is really just the tip of the iceberg. We only used a very simple example to write out to the log on a read operation. In future episodes, we're going to use this to really enhance and further the processing, or even override the processing of the standard event handlers. So we'll come back to this topic again later. And in next week's episode, we'll continue down this path. So far, we've only really impacted the standard create, update, read operations of an service in our cloud application programming model. But I also want to show you how we can influence the bootstrapping of the whole standard service handler framework to completely override it or enhance it with your own custom logic as well.